All right, I am finally ready. We're gonna get started right at the beginning of chapter 2. So you finished up your chapter 1 last week. The test, like I said, I will have that out for you probably tomorrow once everybody gets a chance to make it up, but your grades are in the grade book. So I asked you to pick up the chapter 2 packet and take out your reference table. So does everybody here have their reference table? Okay, so we will need that. We're gonna start right with chapter 1, right with chapter 2 on page 1. And it says Earth's shape. And everybody already joked, what's the shape of the Earth?
Flat.
Of course it's flat. So everybody used to think the Earth was flat. That was a thing. You guys know that. Okay, so anyway, you can keep your own personal beliefs to what you think the Earth's shape is. Know that what is going to be on the test is what I'm going to be teaching you right now, though. So we're going to start with, what is it?
Circle.
It's not. It's not.
It's
not.
Square.
It's not.
Plane.
It's not. It is what's called an oblate spheroid. Right there where it says Earth shape on the top of page 1. You have been lied to your whole life. It's not a sphere. It's an oblate spheroid.
It's the same thing.
It's not. So a sphere, we're going to get there. Guys, we're going to get there. So what is an oblate spheroid? An oblate spheroid is basically a sphere, except it's slightly bulging in the middle. A perfect sphere would be the same height as it was fat. A basketball is the same height as it is fat. The Earth, however, is slightly fatter at the equator, that middle, that's the middle I'm talking about. So it does bulge out a little at the equator. So if you measured from the North Pole to the South Pole through the center of the Earth, that number would be slightly less than if you measured from going across the globe. Oh, I can. Oh, and I broke the cover doing it. That's good. All right, so like I was saying, it'll be slightly shorter here to here than it is from here to here. It's not noticeable. It's not enough to notice, but it is if you actually got out some sort of measuring device. It would be shorter. Yeah. No, that's not the evidence. So that's all for the Earth shape. And this shape is due to the fact that the Earth is spinning like this. Very similar to if you take a hunk of pizza dough, okay, pizza dough, what do fancy pizza dough makers do to make it spread? They spin it.
Throw it in the air.
Yeah. Luckily, the Earth is not made out of pizza dough because then what would we be?
Flat.
We would be flat. So we're not made out of pizza dough, but there is some materials that can be shaped a little bit. So because of the spinning like that, the rotation, it is kind of getting fatter in the middle, just like the pizza ends up spreading out like that. So that's an oblate spheroid. So you do have to know the official, oh my, words are coming difficult for me. You do need to know the official shape of the Earth is an oblate spheroid. And then you want to know, how do we know this? Because you walk outside and other than having some hills and some mountains and some valleys, I'm looking out there, the Earth does not look round. The Earth does look flat to me. I agree with you. And I agree with those people in the olden days who are like, looks flat to me. So we need some proof. Some of the proof is,
whoa.
Yeah, that's a lot of, so I'm going to give you some time to write those. Sorry. But once you write those are pretty, we're not going to do too much more after that. So what? Oh. All right, everybody looks like they're just about done writing. You guys can keep writing while I'm talking. So for the evidence, the first piece of evidence was when all the wives were sitting at the beach. Well, it wasn't really considered a beach back then, but sitting at the shore, waving to their loved ones as they went out on the shipping trek that they weren't sure if they were gonna ever come back from. When they were sitting there watching the boat, if a boat was sailing, and I had the worst boat ever here. Somebody can make me a better boat later. If a boat was sailing on a flat earth, how would the ship disappear when if it got to the edge? It just fall off, right? Like kind of like that, it would tip over and fall off. But what they noticed was when it went around the curvature of the earth, it kind of didn't just tip over and fall off. It kind of disappeared like this because the boat was going around a round object, not falling off a flat surface. So it would kind of just go like that down. That was, they probably didn't think anything of it. They saw it, didn't think anything of it. But then a few other things started to pop up. When the Earth's shadow appears on the moon during a lunar eclipse, what shape covers up the moon? A circle.
Like an oblate spheroid.
Good, that's actually a better answer. An oblate spheroid appears, yes. A circle covers the moon. So whatever was doing the covering, the shadow was a circle shape. Again, they didn't even know what that was either, so that didn't matter. But now we've got two pieces of evidence kicking around. Another thing, do you guys know what causes daytime and nighttime? The sun, and right, so just actually the sun. So if the sun was out shining on a flat earth, whether it was coming at the earth like this, so if my hand had a flashlight in it, or if it was shining at the earth like this, what time would it be on the whole earth?
Same time.
The same time. Everybody would either have the daytime on this side, or if the sun was over here, nighttime. Do we know that to be true, that it's either the same time or completely? It's different. So when the sun is shining here, hitting the earth, here it's gonna hit at noon, here it's just gonna be morning, here it's gonna be just becoming evening, and this side's going to be all the different times at night. So again, that piece of evidence, once they started exploring the whole world and they realized it wasn't the same time everywhere, they knew that it couldn't be a flat surface. Yeah.
I have a question there. So if we're here
Yeah.
on the very opposite side of the moon, wouldn't it be like it's 5 here? Wouldn't it be like 5
Oh, do you mean moon or earth?
AM or PM?
Do you mean moon or earth? That's why we have to be
On the earth?
okay, on the earth. So if we're here and they're here,
Yeah.
they're exactly opposite.
And my second question.
Yeah.
Do you think there's actually a rectangular planet?
No, I do not. Physics can't make that happen. Another thing that they started to notice when they started paying more attention to the stars, one particular star, which is Polaris, not the snowmobile.
Oh,
I'm
man.
talking about Polaris is the official name for the star that's called the North Star. They would notice that this star would be in different spots depending on where they were in their travels. So the stars looked like they were moving. And then finally, once we got photographs from space, they're like, oh, that is absolutely a circle, a spheroid. We can't argue anymore. The Earth is definitely a sphere. So that is all the pieces of evidence that the Earth is actually not flat, but in fact round, or more specifically an oblate spheroid. Speaking of spheres, the Earth is broken into spheres, different spheres of the Earth. What? No, that's not the spheres I'm talking about. I am talking about the lithosphere, the hydrosphere, and the atmosphere. Ever heard of any of those?
Yeah.
Definitely. I think you've heard of the atmosphere. Where's the atmosphere? What is the atmosphere?
Right?
Yeah. The atmosphere is all the air that is surrounding the Earth. So right now, our bodies are in the atmosphere. Have you heard of either one of those other ones, lithosphere or hydrosphere?
Yeah, I've heard of hydrosphere.
You've heard of hydrosphere? Know what it is?
No.
No.
Wait, what if it's the other layer? It makes power plants.
Maybe. What somebody said over here. Water. It's the water layer of the Earth. You did say that too. Hydrosphere, like hydrate or fire hydrant, not like just plain old hydrogen. It's not the hydrogen layer. It's the water layer. And then somebody said they heard the lithosphere. So we so far have the air layer, the water layer. What do you think the lithosphere is?
Isn't that like one of the top?
Guys, will you? What?
Isn't that one of the most, like the very top things?
It is. It is the rock layer of Earth. So we're going to start with that one right there on the middle of page 1. The lithosphere is the solid part of Earth. It does include the crust and upper mantle, bedrock, which is the continents, and the ocean floor. All right, so that's the lithosphere. The hydrosphere, like you guys already said, is the water that's on Earth. It does include What?
All the water?
All the water. So it includes ocean, lakes, rivers, and the groundwater. So like water you get from like wells,
Like the water bottle.
water in the water bottles is still part of the hydrosphere. I think you already kind of know this fact that approximately 75% of the Earth's surface is covered by water.
Yeah.
If you look at a globe, if you look at a map, there's more water than there is land.
Which is
You're fine.
Well, I'll just figure out like 75%.
Well, they just did some measuring. It's approximately. Yeah. All right, and the last layer we're gonna worry about for right now is the atmosphere, which is a shell of gases that surround, so it's the shell of gases that surrounds Earth. It's divided into layers based on composition and temperature. Then I have this word troposphere already written for you. The troposphere is just the layer that's closest to Earth's surface. It's most important. And that's where it contains all the elements necessary for life. When you're done with that, we're going to need our front page of our reference table. So we're going to look at what I feel like is the easiest reference table that is on all of the reference tables. So the easiest chart that's on all of the reference tables. And that chart's right on the front cover of your reference table, so we don't have to go too far when looking for this in your packet. Everybody good with the notes on the board, or should I leave them there for a second? So this first reference table, so we've already looked a little bit around the reference table. So we've established that it's kind of broken up into kind of different tables on each page. I want to look at this one right here on the front cover, the bottom of the front cover. This one is the average chemical composition of the Earth's crust, hydrosphere, and troposphere. What's composition mean to you? Not the texture, it's it's a notebook, is that what you said? What it's made up of. So if you didn't know that, which none of you answered that right away, make sure you put a little note next to this. It's the chemical makeup. Now, I know you guys know a little teeny tiny bit. When I say chemistry, you do know a little teeny tiny bit. Just a tiny bit. In 8th grade, do you remember looking at this, or 6th grade? 6th, 7th, and 8th grade, possibly? I was just gonna ask, what is this called? The periodic table. And what are each one of those things in each box?
Elements of-
Those are elements. Good news, you don't need to know anything about that for this year. What you do need to know is that these, right there, what are, they're listed as elements. So just keep in mind, those are those that were on the periodic table. You don't have to memorize any letters, because as you see here, they tell you O is oxygen, Si is silicon, Al is aluminum. So you just kind of need to like think about, okay, when they say elements, they're talking about those things. And that's all you need to know is that that's there. Then they tell you in each layer, so here's the crust, here's the hydrosphere, here's the troposphere. They tell you the percent in over here, it's a percent by volume of each one of those elements. So let's take a look at the hydrosphere and the troposphere compared to the crust. What's the first thing you might notice? So look on your chart. What do you notice about the hydrosphere and the troposphere compared to the crust? They don't have a lot of elements. So by the way, the blank spaces, what do the blank spaces mean? There's nothing in them. So there is no silicon in the troposphere. The only thing in the troposphere, we've got 21% oxygen, believe it or not, 78% nitrogen and 1% other. In water, what's water made out of? What do you guys already know off the top of your head? Water is made out of
Oxygen, water.
hydrogen and oxygen, H2O. Look at that. O is 33, H is 66, H2O. So there's two H's, that's why it's double. That's just extra. And then there is a little bit of other stuff listed. So there's way more things in the crust. They do list them here two different ways, percent by mass and percent by volume. So that's just how much they weigh compared to how much space they take up. One more thing before I go ahead, and yes, you are going to have homework, but it's going to be super easy. If you had to sum up in one word, what is the troposphere made out of? Without even looking at the list. No. What's, it's the atmosphere. So what's the atmosphere made out of? Gases. This is made out of air. What's the hydrosphere made out of?
Gases.
No, hydrosphere.
Water.
Water. And we already said the lithosphere and the crust is what we're walking on. So is there one simple word for what we're walking on? Solid rocks. Earth. Rocks. So that might help you to keep these straight. The hydrosphere is made out of water. The troposphere is made out of air. The crust and the lithosphere are made out of rocks. So your homework is going to be pages 3 and 4. But we're going to show you just how easy this is. Before we get started, though, I want to make sure you guys know what the word abundant means. Big amount. It's a huge amount of something. So when they say blank is the most abundant element in the Earth's hydrosphere, what are they asking you? What is the most, or what element takes up most of the hydrosphere? So let's take a look at that. Go to the hydrosphere. Yeah, which one's the most? Hydrogen. So I'm just asking you to fill in the blanks here. Thanks. No, positive. No, I'm positive I don't. The chemical composition for calcium, how will we figure this out?
Where do you see it?
Yep, right there.
Yeah.
Calcium in parentheses, Ca. All right, I'm gonna stop talking so I stop coughing and let you figure this rest out on your own. So you are going to do pages 3 and 4, just the questions. You have about 6 minutes to finish that right now. Yeah,